According to NASA, the fundamental principles of rocket science begin with Galileo and Isaac Newton. Galileo discovered inertia, the idea that objects with mass will resist changes in motion. The more mass an object has, the more resistant it will be. Newton's laws state that 1. An object at rest and in motion will remain that way unless acted upon by an outside force. 2. Force equals mass times acceleration. And 3. For every action there is an equal and opposite reaction. Newton's first law and Galileo's law of inertia must both be applied when taking into account the liftoff of a rocket. This is what is called an unbalanced force, or in other words, what happens when one force is stronger than another. In order to leave the ground, the thrust force of a rocket must be greater than gravity, as well as drag. Drag is the friction created by Earth's atmosphere that helps with the unbalancing process, but it's entirely absent in space. Once a rocket leaves the atmosphere, Earth's gravity will still act upon it, but the lack of drag will keep the rocket in a forward motion, forever. Newton's second law, commonly abbreviated as F equals ma, is very applicable to the thrust of a rocket. The amount of propellant burned per second and the acceleration are equivalent to the rocket's overall thrust. Now, in terms of physics, there is a reaction for every action. This is Newton's third law, but what we see in rocket science is that the explosion of gas, smoke, and flame from the nozzle is the action, a strong force downward. As a result, this causes a strong reaction against gravity, propelling the rocket in an upward direction. The reaction and action are equal, and while the rocket accelerates much slower than the explosion from the nozzle, we must take into account that this is because the mass of the rocket is much greater than the burning propellant. An object with a large mass will also require a large force to move it. Something that needs to be taken into consideration is the constant changing mass of the rocket. Every bit of rocket propellant has mass, but as it burns, the rocket slowly loses weight and mass, causing it to accelerate more and more. Even at a slow rate of acceleration, the rocket will continue to become faster and faster as the acceleration accumulates.